Space is a silent ocean of darkness, dotted with more than just stars and planets. Orbiting our world and drifting through the solar system are the forgotten, the lost, and the truly bizarre artifacts of human exploration. By the end of this journey, you will have discovered 30 of the strangest objects we have left floating in the void. We will uncover everything from a ghostly satellite older than your grandparents to a car cruising past Mars. What do you think is the most unusual thing we have ever sent into the cosmos? High above our heads, a silent metallic sphere no bigger than a grapefruit has been tracing endless loops around the Earth for over 6 decades. This is Vanguard 1, the oldest human-made object still in space, a ghost from the very dawn of the space age. Launched by the United States in March of 1958, it was a tiny pioneer in a race for cosmic dominance. Its mission was deceptively simple: to test the effects of the space environment on a satellite and to precisely measure the shape of our planet. While its scientific work ended long ago, its journey is far from over. Vanguard 1 is still up there, a speck of polished aluminum and steel silently crossing the night sky, and according to orbital calculations, it is not coming down anytime soon. This little satellite, a relic from a time of vacuum tubes and slide rules, is predicted to remain in orbit for another 240 years. It is a permanent monument to our first tentative steps off our home world, destined to outlive every person currently on the planet. But that pioneering satellite is not the only piece of our history circling the globe. Some of the strangest objects in orbit were never meant to be there at all. Drifting just ahead of the International Space Station is a tool bag, a mundane collection of grease guns and scrapers that escaped from an astronaut's grasp. During a spacewalk in November of 2008, astronaut Heidemarie Stephanischen Piper was attempting to clean a gummed-up joint on the station's solar array. As she worked, a crucial tool bag inadvertently drifted away, a small dark shape swallowed by the immense blackness. It was instantly transformed from a simple maintenance kit into a new, independent satellite. For a time, this lost toolkit was so reflective and tumbling in just the right way that it became one of the brightest objects in the night sky. Amateur astronomers on Earth could actually spot it with binoculars, a gleaming white dot chasing the station it once served. It was a surreal sight, a humble tool bag orbiting our planet at over 17,000 miles per hour. This ghostly piece of hardware remained in space for months, a silent testament to a single, costly mistake. Eventually, as was always its fate, it fell into the thicker layers of our atmosphere and burned up in a brief, final flash of light. Far above the Earth, a different kind of ghost is said to haunt the void, one wrapped not in history but in pure mystery. For decades, stories have swirled about the so-called Black Knight satellite, a dark, alien object that has supposedly been orbiting our planet for 13,000 years. The tales describe it as an artificial construct of unknown origin, silently watching us from the darkness, a piece of extraterrestrial technology monitoring human civilization. It is a story that has inspired countless articles, documentaries, and a deep, unsettling fascination with the idea that we are not alone and that we are being watched. The reality, however, is far more terrestrial, yet in its own way just as strange. The most famous image of the Black Knight is almost certainly a thermal blanket lost during a spacewalk from the International Space Station. Astronauts had been installing equipment, and the blanket, designed to regulate temperature, simply floated away, becoming another piece of human-made debris tumbling through space. So why does the legend persist so powerfully? It taps into a fundamental human desire for mystery, for the possibility that the cosmos holds ancient secrets far beyond our understanding. The Black Knight is not an alien probe, but it has become something else entirely, a modern myth born from our own fears and wonders, a phantom crafted from misidentified debris and the boundless imagination of a species looking up at the stars and longing for contact. While myths of phantom satellites capture our imagination, one of the most audacious and verifiably real objects in space is a cherry red sports car. In February of 2018, SpaceX launched its first Falcon Heavy rocket, a powerful new vehicle that needed a test payload. Instead of using a standard block of concrete or steel, the company's founder, Elon Musk, decided to send his own personal Tesla Roadster on a one-way trip to the asteroid belt. Strapped into the driver's seat is a mannequin nicknamed Starman, dressed in a full spacesuit, its left hand resting casually on the steering wheel as if out for a Sunday drive. A camera mounted on the car gave us a series of breathtaking views, with Starman cruising against the backdrop of our distant, swirling blue and white planet. The dashboard screen even displays the words "Do not panic," a playful nod to the science fiction series The Hitchhiker's Guide to the Galaxy. This was not just a launch, it was a spectacle, a piece of performance art played out on the grandest possible stage. Today, the Roadster and its silent passenger are far, far from home. The vehicle is in a wide elliptical orbit around the Sun that takes it from inside Earth's orbit all the way out past the orbit of Mars. At its farthest point, it is over 200 million miles from us. It has already completed several loops around our star, a ghost car on an endless cosmic highway. What will future spacefarers think if they ever encounter this pristine relic? A cherry red convertible silently gliding through the void with a spacesuit-clad driver forever frozen in time. It is arguably the quirkiest, most personal artifact humanity has ever cast into the depths of the solar system. Even the most mundane human activities take on a surreal quality in the vacuum of space. High above us, the International Space Station has developed a strange, almost poetic method for dealing with a very basic biological reality. When the station's waste tanks become full, they are emptied directly into the void. This includes water recovered from the astronaut's own urine, which is purified and recycled for drinking, and the concentrated brine that is left over from that process. During a routine waste venting, this liquid is released through a special port on the station's exterior. The moment it hits the vacuum, it doesn't simply drift away. It instantly flash freezes, transforming into a cloud of countless microscopic ice crystals. To an astronaut watching from a window, it looks like a sudden, silent explosion of glittering dust, a temporary constellation that shimmers for a few moments against the blackness before dispersing. This bizarre yet routine procedure is a stark reminder that life in orbit requires solutions that would be unthinkable on Earth. Every aspect of existence, even the disposal of what the body no longer needs, becomes a carefully choreographed operation against an utterly unforgiving environment. These frozen clouds are a temporary, man-made phenomenon, a fleeting monument to the practical challenges of keeping humans alive among the stars. While we have sent cars into the void and intentionally jettisoned waste, some of the most poignant items in orbit were lost by pure accident. During the first American spacewalk in June of 1965, astronaut Ed White made history floating outside his Gemini 4 capsule, connected only by a thin umbilical line. The sheer joy of that experience was palpable as he used a handheld gas gun to maneuver, describing the view as the saddest moment of his life when he was ordered back inside. But in the process of re-entering the cramped cabin, a single, crucial item slipped away. One of his gloves, a vital piece of his pressurized spacesuit, drifted free and was left behind. In an instant, that glove was transformed. It was no longer just a piece of equipment, but a new, solitary satellite. For an entire month, this ghostly glove orbited our planet, a silent and personal memorial to a historic human achievement. It traveled at thousands of miles per hour, a stark white shape tumbling endlessly through the void, a constant reminder of the astronaut who had just been there. Can you picture it, a single glove, alone in the immense darkness with the entire Earth spinning below? it became one of the very first and most human pieces of space junk ever created. There was no way to retrieve it, no mission to go and collect what was lost. It simply had to complete its own final, lonely journey. After circling the world for weeks, the glove's orbit inevitably decayed. It dipped into the upper atmosphere, where friction with the thin air generated intense heat, causing it to burn up in a brief, final streak of light. That lost glove symbolizes a profound truth about our presence in space, that every step we take beyond our world is accompanied by a trail of artifacts, some grand and intentional, others small, personal, and entirely unexpected. A toolkit failure can transform a simple screwdriver into a permanent, high-speed resident of space. During a spacewalk in 2008, astronaut Stephen Piper was performing vital maintenance outside the International Space Station when a startling mishap occurred. A small, crucial spring inside her tool bag's lubrication gun failed. This tiny mechanical part, no bigger than your fingernail, set off a chain reaction. The failure caused grease to leak everywhere, coating the entire kit and its contents. As she worked to clean the mess, the entire bag, complete with a grease gun, a socket, and a single screwdriver, drifted from her grasp. In the blink of an eye, these mundane tools were no longer instruments of repair, but independent satellites set adrift on an unstoppable trajectory. They did not simply vanish into the distance. Instead, they began their own silent, elliptical dance around the Earth. For months, this ghostly assortment of hardware traced a path just ahead of the space station, a constant, orbiting reminder of the incident. Each piece, from the gun to the screwdriver, became a tracked object, catalogued by space agencies as they whizzed around the planet at over 17,000 miles per hour. Their journey, however, was not eternal. The gentle but persistent drag of the Earth's outer atmosphere slowly but surely tugged at their orbits. Over time, their path decayed, pulling them lower and lower until they finally met their inevitable end. They plunged into the thicker air, where friction generated immense heat, vaporizing the tools in a final, fiery flash. This entire event underscores a profound reality of working in orbit, that the line between a held tool and a new piece of space debris is terrifyingly thin, a separation measured only by a secure grip and a spring that did not break. A single high-definition camera worth tens of thousands of dollars is now an untethered satellite. During a routine spacewalk outside the International Space Station, an astronaut was preparing to document some external repairs. In the careful, deliberate ballet of a spacewalk where every tool is secured, a moment of distraction is all it takes. The camera, likely attached to a tether that was not properly secured, simply drifted away from the crew member's grasp. There was no gust of wind to blame, no sudden jolt, only the relentless and silent physics of microgravity. One moment it was a vital piece of equipment, the next it was a shrinking dot against the incredible backdrop of the Earth, lost forever. This was not a cheap consumer model, but a sophisticated piece of hardware designed for the harsh conditions of space, and its loss was a significant, costly mistake. Its journey did not end with its disappearance from view. The camera entered its own independent orbit, a new piece of debris added to the growing cloud encircling our planet. It began to travel at the same incredible speed as the station itself, approximately 17,500 miles per hour. At that velocity, even something as small as a camera carries the destructive force of a grenade. This is the central dilemma of space debris, that every lost item, no matter how valuable or seemingly insignificant, becomes a permanent hazard. Tracking networks on Earth, with their powerful radars and telescopes, can follow objects as small as a softball in low Earth orbit. A camera is larger than that, so it was almost certainly added to the official catalog of space junk. Its orbit calculated and its path monitored to ensure it does not threaten other satellites or the space station it once served. Yet, its story highlights a terrifying vulnerability. The very environment that allows astronauts to float and work with such grace is also what makes it so easy to lose things and so difficult to ever get them back. Each lost item, from a tool bag to a camera, adds another invisible bullet to the orbital shooting gallery we have created around our world. That lost camera was a costly mistake, but some objects are ejected from the station with deliberate, calculated intent. In July of 2007, astronauts aboard the International Space Station opened an airlock and pushed out an object the size of a large refrigerator. This was no simple bag of tools. It was a 1,300-pound tank of highly toxic ammonia. For years, this massive reservoir served as a vital part of the station's cooling system, circulating fluid to keep the electronics and living quarters from overheating in the relentless glare of the sun. But the system was upgraded, and the old tank, now obsolete and taking up valuable storage space, had to go. There was no spacecraft capable of bringing it back to Earth, and simply keeping it on board was not an option. So the crew, following a carefully designed procedure, sent it on a one-way trip into the void. Imagine the sight: a white cylindrical tank, massive by the standards of spacewalking, slowly tumbling away from the station, shrinking into the darkness until it was just another star in the firmament. This was not an accident, it was a necessary act of cosmic housekeeping. For 3 years, this ghost tank orbited our planet, a silent and hefty piece of controlled space trash. Its journey, however, was never meant to be permanent. The gentle but persistent tug of Earth's gravity and the faint resistance of the upper atmosphere were always at work, slowly stealing its energy. In November of 2010, its orbit finally decayed enough for it to make a dramatic return. Plunging into the atmosphere at over 17,000 miles per hour, the immense tank was met with friction that heated it to thousands of degrees. It did not simply vanish, it put on a spectacular show. Witnesses on the ground across the Pacific Ocean reported seeing a brilliant fireball, a string of incandescent fragments streaking across the night sky as the tank violently broke apart. Every piece that did not completely vaporize fell harmlessly into a remote stretch of ocean. This event was a stark demonstration of scale, proving that the largest pieces of debris we intentionally create are still subject to the same ultimate fate, a controlled and fiery re-entry. The dangers of orbital debris are not confined to large, discarded tanks. A simple pair of pliers, no heavier than a standard tool you might find in a garage, became a stark demonstration of this threat. During a complex spacewalk to service the International Space Station, an astronaut was working with a pair of utility pliers, a fundamental tool for gripping and manipulating components. In the demanding environment of a spacewalk, where every motion must be deliberate, the pliers were momentarily set adrift. Without the pull of gravity to bring them down, they simply floated away, joining the growing population of man-made objects circling our planet. This was not a planned disposal, but another accidental contribution to the orbital junkyard. While a pair of pliers seems insignificant, its potential for destruction was immense. Traveling at orbital velocities of roughly 17,000 miles per hour, even this small tool carries the kinetic energy of a powerful explosive. A direct impact from such an object could shatter a satellite solar panel, puncture a pressurized module, or disable a critical sensor. The pliers were immediately catalogued by military and civilian tracking networks, their path monitored to ensure they did not drift back toward the station or any other valuable asset. For months, these lost pliers traced their own silent, high-speed arc around the Earth, a constant reminder that in the unforgiving economy of orbit, there is no such thing as a harmless mistake. Every single item, from a massive ammonia tank to a humble hand tool, becomes a permanent high-velocity hazard, turning the space around our world into an ever more crowded and perilous environment. Sometimes our attempts to clean up our own mess in space leave behind their own unique debris. In the mid-1980s, 2 brand new communication satellites suffered nearly identical and catastrophic failures. The first was an American satellite called Westar 6, and the second was an Indonesian satellite named Palapa B2. Both were successfully launched into space, but their booster motors, the rockets designed to push them up into their final high orbits, malfunctioned. Instead of climbing to their intended positions over 22,000 miles above the Earth, they were left stranded in useless, low orbits, slowly drifting and utterly useless to their owners. They were multi-million-dollar assets that had become little more than expensive, orbiting paperweights, but NASA saw an opportunity for a spectacular demonstration of its space shuttle's capabilities. In a daring and unprecedented mission, the Space Shuttle Discovery was sent to retrieve them. Astronauts performed a series of complex spacewalks, capturing the massive, bus-sized satellites and carefully maneuvering them into the shuttle's cargo bay. It was a monumental achievement, a cosmic salvage operation that brought two lost birds back to the nest. However, the story does not end with a perfect cleanup. To fit the satellites inside the bay, the astronauts had to remove certain components, including the large, conical adapters that had connected each satellite to its failed booster motor. These heavy, hollow metal cones were simply too bulky to bring back. With no other viable option, the astronauts released them into space. So while the valuable satellites were safely returned to Earth, their adapters were left behind. Today, decades after that historic rescue mission, those two discarded cones are still up there. They continue to orbit our planet, silent and empty, tracing endless circles as memorials to a salvage operation that was almost but not entirely complete. They are a peculiar kind of artifact, remnants of one of the most ambitious repair jobs in the history of spaceflight, proving that even our greatest successes in managing orbital debris can still leave a permanent trace. The true danger of orbital debris is not always measured in pounds or feet. It can be as small and seemingly insignificant as a flake of paint. During one space shuttle mission, astronauts conducting a routine inspection of the vehicle made a startling discovery. A tiny chip, no larger than the head of a pin, was embedded in one of the thick, multi-paned windows. The culprit was almost certainly a microscopic fleck of paint that had broken away from an old rocket or satellite. How could something so small cause visible damage? The answer lies in the brutal mathematics of orbital speed. That speck of paint was not drifting lazily. It was traveling at a relative velocity of over 17,000 miles per hour. At that speed, mass becomes almost irrelevant. The kinetic energy it carried was comparable to a bowling ball dropped from a multi-story building, all concentrated into a point smaller than a grain of sand. The window, made of incredibly strong fused quartz and aluminum, was designed to withstand such impacts, and it did its job perfectly, but the scar it bore was a permanent warning. This single event perfectly illustrates the terrifying reality of the Kessler syndrome, a theoretical scenario where the density of objects in low Earth orbit becomes so high that collisions create more debris, triggering an unstoppable cascade. Each new fragment, whether a discarded bolt or a flake of paint, becomes another bullet in a cosmic shooting gallery. The space around our planet is not an empty void. It is a hazardous environment filled with millions of these tiny, high-velocity projectiles, each one capable of crippling a satellite or threatening the lives of astronauts aboard the International Space Station. The greatest threats in orbit are often the ones you cannot even see. Even the smallest actions on the Moon had permanent consequences. During the Apollo missions, astronauts used specially designed cameras to document their historic walks on the lunar surface. These cameras were sealed in protective containers, and before they could be used, a simple but crucial step had to be taken. The astronauts would pop off the lens cap and, with no atmosphere to slow it down, simply toss it aside. In the Moon's low gravity, that tiny piece of metal or plastic was given an escape velocity it could never achieve on Earth. With a casual flick of the wrist, these lens caps were launched into their own independent trajectories, becoming the most humble of artificial satellites. They did not simply fall to the lunar dust. Instead, they sailed off into the blackness on a path dictated entirely by that initial toss and the gravitational pull of the moon and the sun. Where are they now? It is a fascinating cosmic mystery. Some of these caps were likely thrown with enough force to achieve a stable orbit around the moon itself. They could still be circling our celestial neighbor even today, silent and unseen. Others may have been nudged by the complex gravitational interplay between the Earth and the Moon, eventually being cast adrift into a permanent orbit around the Sun. Think about that for a moment. Somewhere in the vast emptiness between the planets, a handful of lens caps, each no bigger than the palm of your hand, are tracing an endless, silent path around our star. They are not space junk in the traditional sense, but tiny, polished relics of one of humanity's greatest adventures. They are not tracked or catalogued, their exact locations lost to time. They are simply out there, ghostly souvenirs from the moment we first set foot on another world, destined to drift for millions of years as permanent, if minuscule, monuments to human curiosity and our fleeting presence on the lunar surface. The silent graveyard of orbit holds more than just lost tools and frozen waste. Some of its residents seem to defy the finality of death itself. In 1965, a small satellite named LS-1 was launched into space. Built by the Lincoln Laboratory at the Massachusetts Institute of Technology, its mission was to test new military communication technologies, but a simple wiring error during its deployment sent it tumbling uncontrollably. Its solar panels could not lock onto the sun, its batteries drained, and it fell silent. For 46 years, it was just another piece of dead metal in the catalogue of space junk, a forgotten relic from the earliest days of satellite technology. Then, in 2012, an amateur astronomer in England named Phil Williams was scanning the radio waves, listening for signals from old satellites. To his absolute astonishment, he picked up a faint, ghostly transmission. The signal was a simple, repeating pulse, a steady beep, beep, beep cutting through the static. When he traced its origin, he found it was coming from LS-1. The satellite that had been declared dead for nearly half a century was suddenly, inexplicably, talking again. How could this be? The leading theory is as strange as the signal itself. Over decades in space, a satellite's orbit is constantly perturbed by the subtle gravitational tugs of the sun and moon. These forces can ever so slowly change its orientation. Scientists believe that after all those years, the satellite's tumble finally brought its damaged solar panels into just the right alignment with the sun. A trickle of power after nearly 5 decades of darkness might have seeped into its dormant systems. This tiny jolt of electricity could have been enough to power a single, simple transmitter, causing the satellite to sing one last, ghostly song from its grave. It was not an alien message or a coded signal, but the random, automated cry of a machine that was never meant to wake up. The phenomenon did not last. After a few years of these intermittent transmissions, LS-1 fell silent once more, likely for the final time. Its brief resurrection stands as one of the most eerie events in the history of spaceflight, a reminder that what we leave in the void is not always as dead and gone as we assume. Floating amongst the civilian tools and forgotten gloves are artifacts from a world of shadows and secrets. The most powerful nations on Earth operate vast constellations of spy satellites, their true capabilities and missions classified at the highest levels. These silent sentinels peer down with unimaginable clarity, but they too are subject to the same laws of physics as every other object in orbit. This means that even these billion-dollar black-budget programs leave their own anonymous debris behind. While we will never see an official inventory, it is almost certain that discarded lens caps, protective sensor housings, and other launch components from these covert missions are adrift in the darkness. Imagine a large, mirrored cover, once used to protect a hypersensitive telescope lens during its ascent. Once in orbit, that cover is jettisoned to allow the satellite to see. It serves no further purpose, so it is cast off to become just another piece of untracked space junk. This discarded hardware carries with it the ultimate anonymity. Its original purpose, the specific frequencies it listened for, or the resolution of its imagery, are secrets known to only a handful of people on the planet. To any observer, it is just another tumbling piece of metal, its true history and immense cost completely invisible. These objects represent a parallel universe of space debris, one where the most fascinating stories are the ones we are never meant to hear. They are the ghostly, unacknowledged footprints of our planet's silent watchers, forever circling with their secrets locked away. Even the most carefully planned spacewalk can produce an unexpected souvenir. During a routine maintenance procedure outside the International Space Station, an astronaut was removing a piece of old insulation. This was no ordinary blanket, but a complex sheet of multilayer insulation, a metallic fabric designed to reflect the sun's intense heat and protect the station's delicate components. In the silent, airless environment, as the astronaut worked to peel it away, a section tore loose. For a moment, it was just a crumpled sheet in a gloved hand, and then with a slight push, it was gone. It did not float gently downward, it simply drifted away, a silver scrap set adrift against the infinite black. In an instant, this piece of protective shielding was transformed. It was no longer part of the station, but a new, independent object catalogued by ground control as another piece of space debris. What makes this particular fragment so strange is its behavior. Unlike a solid tool or a heavy tank, the thin, flexible blanket is incredibly light. It tumbles and flutters in an unpredictable ballet, its orientation constantly changing as it catches the subtle pressure of sunlight itself. This chaotic motion makes it a nightmare to track with precision. One moment it can be a dark, invisible speck, and the next, as it twists at just the right angle, it becomes a brilliant flash of reflected sunlight. To an observer on Earth with a powerful telescope, it would appear as a fleeting, erratic star, winking in and out of existence as it tumbles through the void. This lost thermal blanket is a perfect example of how even the most mundane materials become extraordinary in the environment of space. A shimmering, unpredictable ghost born from a simple tear and set on a permanent, silent journey around our world. The darkest relics in orbit are not merely lost or forgotten, they are actively dangerous. During the height of the Cold War, the Soviet Union launched a secretive fleet of satellites known as ROSAT, an acronym for Radar Ocean Reconnaissance Satellites. Their mission was to track NATO naval vessels from space, a task that required immense power to operate their powerful radar systems. Solar panels would not suffice, so Soviet engineers made a fateful choice. They equipped these satellites with compact onboard nuclear reactors. These were not simple radioisotope heaters like those on some American probes, but full-fledged fission reactors, generating heat that was converted into electricity. When a ROSAT mission ended, or if the reactor was failing, a standard and terrifying procedure was initiated. To prevent the radioactive core from re-entering Earth's atmosphere and scattering contamination across the planet, the satellites were commanded to boost their reactor cores into a much higher orbit, a so-called graveyard orbit nearly 700 miles up. There, the core would be left, a radioactive casket circling the Earth for centuries. This plan was chillingly logical, but it was not foolproof. In 1978, one of these satellites, Cosmos 954, suffered a critical failure and did not boost its reactor properly. It began a chaotic, uncontrolled descent. As it fell, the world watched in horror, waiting to see where the radioactive debris would land. The reactor ultimately disintegrated over northern Canada, scattering particles across a remote area of the Northwest Territories. The clean-up operation, led by the Canadian government with Soviet assistance, was a massive and costly effort, a stark warning of the consequences when nuclear power in space goes wrong. But the cores that made it to the graveyard orbit were arguably an even greater long-term problem. they are still up there, dozens of them, each one a dense, radioactive mass of uranium fuel and reactor components. They do not pose an immediate threat to Earth, safely locked in their high vault, but they represent a permanent and toxic legacy. For any future mission that might venture into that orbital belt, these cores are navigational hazards of the most sinister kind, silent, hot, and waiting. They are the ultimate ghost ships, remnants of a secret war that never happened, carrying a danger that will outlive us all. Sometimes the most dangerous objects in space are the ones we deliberately let go. A spacewalk is a meticulously choreographed ballet, and every tool an astronaut carries is a potential hazard if it drifts free. But what happens when a tool has served its purpose and is no longer needed? The protocol is starkly simple and counterintuitive. If a tool cannot be safely returned to the airlock, it must be intentionally jettisoned into space. This is not an act of carelessness, but a calculated decision to prioritize the safety of the astronaut and the station over the long-term problem of space debris. Imagine an astronaut has just finished tightening a final bolt with a specialized wrench. The job is done, but the tool is now a liability. If it were accidentally lost later, it could float back and strike a sensitive component. So, instead of carrying it back, the astronaut follows a strict procedure. They position themselves on the station's structure, facing the direction of travel, and give the wrench a gentle, deliberate push downward toward the Earth. This specific action, a push towards the planet, ensures the tool enters a slightly lower and slower orbit than the station itself. It is a cosmic version of throwing something off the back of a speeding train. The wrench immediately begins to fall behind, its new orbital path guaranteeing it will not float back and pose an immediate collision risk. It becomes a new, tracked piece of space junk, but one that is now on a slow, decaying journey. For weeks or even months, that solitary wrench will circle the globe, a silent, tumbling symbol of a necessary compromise. Its orbit will gradually decay, pulled lower by the faint drag of the upper atmosphere until it finally meets a fiery end. This is the grim reality of orbital mechanics, that sometimes the only safe way to dispose of something is to add it to the growing cloud of debris. A temporary solution that underscores the fragile and crowded environment we have created just beyond our atmosphere. The most violent acts in space leave behind a permanent scar. In 2007, China conducted a test of a ground-based anti-satellite missile, targeting one of its own aging weather satellites, the Fengyun 1C. The impact was catastrophic. The missile did not just disable the satellite, it obliterated it, striking it at a closing velocity of over 17,000 miles per hour. The event was not a simple puncture, it was a hypervelocity explosion that shattered the one-ton spacecraft into a cloud of fragments. In a single moment, the number of trackable objects in Earth's orbit increased by more than 25%. This was not the slow, accidental accumulation of lost tools, but an instantaneous creation of a debris field containing over 3,000 pieces larger than a golf ball, and an estimated 35,000 pieces larger than 1 centimeter. Each one of those fragments became a new, independent satellite, each one a high-speed projectile capable of inflicting its own catastrophic damage. The cloud expanded over time, its pieces spreading out along the satellite's original polar orbit, creating a wide band of shrapnel that now encircles the globe, crossing the paths of hundreds of operational satellites and the International Space Station itself. This single, deliberate act demonstrated the terrifying reality of a kinetic impact in orbit. It is not like a car crash where the wreckage settles. In the frictionless environment of space, the debris from such an event becomes a permanent and expanding hazard, a minefield that will remain for centuries, a grim testament to the fact that the greatest threats in space can be created in the blink of an eye. A single bolt no larger than your thumb can become a ghost in the machine of space. When a new satellite is released from its rocket, the process is not always perfectly clean. Small but vital pieces of hardware, like the very bolts that hold the satellite in place during launch, are often intentionally fired away by explosive charges or simple springs. Their job is done and they are cast off as useless. In that moment, they are transformed from simple fasteners into something far more menacing. Each one becomes an independent, high-velocity projectile set on an endless and unpredictable path around our planet. The problem is one of scale and perception. Our most powerful tracking networks here on Earth can reliably follow objects down to about the size of a softball. A lone bolt is far smaller than that, a dark, tumbling speck against the immense backdrop of space. It is nearly impossible to consistently track with radar or telescopes, effectively rendering it invisible to our watchful eyes until it is tragically too late. This makes every lost bolt a ghost, a hidden hazard in the orbital shooting gallery. Traveling at 17,000 miles per hour, such a small object carries the kinetic punch of a powerful explosive. A direct hit from one of these untraceable bolts could shatter a critical sensor, disable a multi-million-dollar communication satellite, or puncture the hull of a crewed spacecraft. They are the landmines of low Earth orbit, scattered by the thousands from decades of satellite deployments, each one a silent reminder that even our most successful launches leave behind a legacy of invisible danger. The International Space Station itself occasionally discards pieces of its own skin. After years of exposure to the harsh vacuum of space, certain scientific experiments reach the end of their useful life. These are not simple sensors, but entire suites of hardware bolted to the station's exterior, designed to test how materials degrade under relentless cosmic radiation, extreme temperature swings, and the impact of atomic oxygen. Once their data collection is complete, they become obsolete, taking up valuable real estate on the station's truss. The solution is as final as it is strange. Astronauts following a meticulous protocol will release these bulky packages, shoving them away from the station to clear the way for new research. In an instant, a multi-million-dollar laboratory module is transformed into just another piece of space junk. These jettisoned experiment platforms are unlike any other debris. They are complex boxes, often filled with samples of advanced composites, coatings, and even biological specimens, all now sealed inside a silent, tumbling time capsule. What was once a vital source of data becomes a ghostly collection of scientific artifacts, its internal findings frozen in time. It will orbit for months or even years, a stark white cube or a metallic pallet spinning endlessly until its path finally decays and it vaporizes in a final, fiery conclusion to its mission. This cyclical process of attachment, study, and release is a fundamental rhythm of life in orbit, a necessary act of cosmic housekeeping that constantly adds new, strangely specific relics to the growing collection of human-made objects adrift around our world. A single, violent event in 2009 demonstrates the chain reaction of orbital destruction with terrifying clarity. On February 10th, high above Siberia, two satellites crossed paths. One was Cosmos 2251, a massive 3,000-pound Russian military communications satellite that had been dead and drifting for over a decade. The other was Iridium 33, an active American commercial satellite, a 700-pound relay for a global phone network. They were not on a deliberate collision course, but in the vast and yet increasingly crowded expanse of low Earth orbit, their paths intersected. The result was not a gentle bump. Traveling in opposing orbits at a combined speed of over 26,000 miles per hour, they struck each other with the force of a large bomb. The impact was catastrophic, shattering both spacecraft into a swirling cloud of shrapnel. In an instant, the two satellites ceased to exist, replaced by thousands of new, fast-moving fragments. Among this expanding debris field was one particular piece, a jagged shard of metal and composite material roughly the size of a refrigerator. It was immediately catalogued by the United States Space Surveillance Network, assigned a number, and its orbit meticulously tracked. This was not a lost tool or a discarded tank. It was a newborn piece of debris, born from one of the most significant satellite collisions in history. Today, over a decade later, that specific fragment is still up there. It continues to race around our planet every 90 minutes, a permanent, high-velocity memorial to that split-second crash. Its path is unpredictable, influenced by the subtle push of solar radiation and the faint drag of the atmosphere, making it a persistent navigational hazard for other satellites. This one fragment, along with the thousands of others from that single event, turned a vast region of orbit into a permanent minefield. It is a ghost born from the death of two others, a constant, silent reminder that in the silent ocean of space, a single collision can echo for centuries. A specialized bag of spare antenna parts represents a different kind of orbital ghost. During a particularly complex spacewalk, astronauts were tasked with upgrading the International Space Station's external communication systems. This delicate operation required a kit filled with delicate components, pre-assembled waveguide segments and finely tuned metallic dishes, all secured within a single fabric bag. In the midst of the intricate work, as an astronaut maneuvered to attach a new antenna, the entire bag slipped from its tether. It did not drift away as a single, solid object. Instead, the bag itself began to tumble, and its contents, no longer restrained by gravity, started a slow, silent ballet of their own. The bag gradually twisted open, spilling its specialized inventory into the void. What was once a neatly organized kit became a loose, swirling cloud of high-tech debris. Imagine a handful of polished metal rods, a small parabolic dish, and a tangle of copper wires, all moving together in a loose, chaotic cluster. They do not separate quickly. Instead, they travel as a group, a phantom swarm of what was meant to be an upgrade, now rendered utterly useless. This lost bag of antennas is more than just another piece of junk. It is a collection of potential that was never realized. Each component, engineered with precision and designed to catch faint signals from Earth, now only reflects sunlight as it spins. They are silent, disconnected, and destined to orbit for years as a single, bizarre entry in the catalogue of space debris, a permanent reminder of how easily a mission's critical spare parts can become just another constellation of man-made stars. Far above the bustling traffic of low Earth orbit, there exists a silent, sprawling junkyard reserved for the giants of our communication age. This is the graveyard orbit, a desolate band over 22,000 miles high, where old geostationary satellites are sent to spend their final centuries. The journey there is a spacecraft's last act, a final burn of its remaining fuel to push it a few hundred miles higher, safely out of the way of the valuable orbital slots used by active satellites. It is a cosmic retirement home, a place of eternal silence, or at least it is supposed to be. Among these derelicts is a satellite that never fully went to sleep. Galaxy 15 was an American communications satellite that, in 2010, suffered a catastrophic failure of its command and control system. Its solar panels remained deployed, soaking up power, but its brain was dead. It would not respond to any signal from Earth, yet its main payload, the powerful transponder that beams television signals back to the ground, remained stubbornly active. For months, this zombie satellite drifted silently through its operational orbit, a dead vessel broadcasting a ghostly signal that actually began to interfere with the communications of other, functioning satellites in its path. It was an ethereal and disruptive presence, a television station from a ghost ship, until its slow drift finally carried it out of the way. While Galaxy 15 eventually fell silent, its brief, unresponsive life highlights a chilling vulnerability. What if a satellite in the graveyard orbit itself were to wake up? This is not just a theory. Trackers have occasionally picked up erratic, unexplained signals emanating from this high vault, fleeting transmissions from satellites that were declared dead decades ago. The causes are as mysterious as the signals themselves. A random cosmic ray might strike a dormant computer chip just right, creating a short circuit that brings a single subsystem online for a few minutes. Years of thermal expansion and contraction from cycling between blistering sunlight and frigid shadow could cause two bare wires to momentarily touch, completing a circuit that should have remained broken forever. These zombie satellites do not pose a physical collision threat in their remote orbit, but their phantom signals are a form of electronic haunting. They represent a complete loss of control, a reminder that our most complex machines can sometimes defy their final commands and whisper back to us from the grave, long after we have forgotten they were ever there. A protective shell the size of a small trash can is tumbling silently through the void, a hollow ghost from a moment of connection. When spacecraft like the Russian Soyuz or the newer commercial vehicles approach the International Space Station, their sensitive docking mechanisms and laser-ranging sensors must be kept perfectly clean during launch. They are sealed under protective covers, shields against dust and moisture. Once in the vacuum of space, these covers have served their purpose. With a simple command, small explosive bolts or springs fire, and the covers are pushed away, spinning off into the darkness to clear the way for a safe link-up. In that instant, they are transformed from vital components into anonymous, high-speed debris. These discarded shells are particularly troublesome. Made of lightweight plastic or thin metal, they are hollow and present a large, fragile surface area. To ground-based radar, which relies on an object's density and mass to get a clear return, these covers can be nearly invisible. They are radar ghosts, often skipping in and out of detection as they tumble erratically. Their unpredictable motion, combined with their low mass, makes calculating their future path incredibly difficult. One moment they might present a broad, reflective face, and the next, they could be edge-on, virtually disappearing from tracking screens. This makes them a stealthy hazard, drifting through crowded orbital lanes unseen until a chance collision turns them into a cloud of shrapnel. Each one is a monument to a successful docking, a necessary piece of litter cast aside in the process of building a bridge in space, now left to wander as a permanent, nearly invisible reminder of the delicate logistics of life in orbit. A tiny, sealed cylinder no bigger than a soda can now wanders the void on its own. This is a lost sample container, a miniature vault that once held the key to a critical space experiment. It was designed to expose materials or even biological specimens to the raw environment of space, testing how they withstand radiation, extreme temperatures, and the vacuum itself. During a transfer outside a spacecraft, perhaps from an airlock to an external platform, the unthinkable happened. A tether failed, or a gloved hand misjudged the momentum, and the container drifted free. In an instant, a $1 million research project transformed into a ghost. That small capsule now carries within it a frozen moment of scientific inquiry. It might contain new alloys being tested for future spacecraft hulls, or perhaps extremophile bacteria, studying if life could potentially survive a journey between worlds. Every piece of data it was meant to provide is now locked away, permanently inaccessible, tumbling through the darkness. It is a quiet tragedy of lost knowledge, a tiny time capsule of what might have been, orbiting our planet as a silent, solitary monument to a single, simple human error. A massive curved shell of carbon composite, large enough to cover a school bus, now spins aimlessly in the void. This is one half of a rocket fairing, a protective nose cone that once cradled a precious satellite during the violent ascent through Earth's atmosphere. Its job was to shield its delicate cargo from the crushing forces of launch and the searing heat of friction, creating a smooth, aerodynamic path to the stars. Once the rocket reaches the thin, high air of space, this protection becomes unnecessary weight. Explosive bolts fire, and the fairing splits perfectly in two, its halves peeling away like the petals of a metallic flower to release the satellite within. For most launches, these discarded shells are destined for a brief, fiery demise, falling back to burn up in the atmosphere. but sometimes a fairing is pushed so high by a powerful rocket that it achieves a stable orbit. It becomes a new, permanent resident of the space junkyard, a hollow, half-egg-shaped ghost. One such object is a specific fairing half from a SpaceX Falcon 9 launch. After it completed its primary duty, this particular piece did not fall back. Instead, it was left drifting, a lightweight, empty hull over 16 feet in diameter. What makes this object so strange is its behavior. It is not a dense, solid block of metal, but a vast, brittle shell. It tumbles in a slow, unpredictable wobble, its large surface area catching the faint pressure of sunlight itself. This gentle but constant pushing alters its path in ways that are maddeningly difficult for trackers on Earth to predict. It is a giant, weightless sail, adrift on solar winds, a silent and colossal remnant from the moment a new set of eyes was opened to the cosmos. A snapped cable can become one of the strangest and most dangerous objects in orbit. In the mid-1990s, a joint NASA and Italian Space Agency mission attempted a revolutionary experiment. The satellite, called TSS-1R, was designed to unwind a 12-mile-long, thin wire tether into the space around Earth. The idea was to generate electricity by dragging this conductive cable through our planet's magnetic field, a concept known as electrodynamic propulsion. For a few hours, the experiment worked perfectly, the tether unreeling behind the satellite, a thread thinner than a shoelace stretching across dozens of miles of emptiness. Then, without warning, it broke. The cause was likely a tiny, unseen flaw in the insulation or a micrometeoroid impact. In an instant, the experiment was over, and a new, bizarre object was born. That 12-mile-long tether did not drift away as a loose coil. The forces acting upon it, a combination of gravity and its own stored energy, caused it to whip and straighten out. It became a single, impossibly long filament, a wire as long as a city is wide, now orbiting the Earth independently. Can you picture the sheer scale of it? A thread so thin it is nearly invisible, yet so long that if you were floating at one end, the other end would be over the horizon. This created a unique and terrifying hazard. While the tether itself was lightweight, its length meant that any satellite or piece of debris crossing its path would experience a high-speed impact. It was a cosmic tripwire, a silent, slicing danger that was incredibly difficult to track with radar. This single event demonstrated the dual nature of innovation in space, where a bold attempt to harness new energy sources can, in a moment of failure, create a ghost that haunts the very environment it sought to utilize. Even the most powerful eyes in the universe had to be unwrapped. The Hubble Space Telescope, our window to the deepest cosmos, launched with its delicate optics sealed shut. A large, protective cover shielded its primary mirror from dust and contamination during the violent ascent through the atmosphere. Once in the pristine vacuum of space, that cover had to go. With a series of precise commands, it was unlatched and moved aside, allowing Hubble to see the universe for the very first time. That discarded cover, a dark, circular plate larger than a manhole, did not simply vanish. It was cast adrift, becoming another autonomous object in the crowded orbital lanes. For years, this specific piece of Hubble's berth has been circling our planet, a silent, black ghost from one of humanity's greatest scientific achievements. Its journey is a solitary one, but it occasionally makes a phantom appearance. As it tumbles in its orbit, it can drift directly through the field of view of other telescopes, both on the ground and in space. Imagine an astronomer peering at data from a sensitive observation, suddenly finding their view of a distant galaxy momentarily eclipsed by a fast-moving, man-made shadow. For a few seconds, the data stream is interrupted by a dark, unrecognized shape. By the time they realize what it was, the cover is already thousands of miles away, continuing its endless, silent loop. It is a bizarre form of cosmic irony that a piece of the very instrument that opened our eyes to the heavens can now, however briefly, shut our view of them down. This relic is a permanent part of Hubble's legacy, a footnote to its story of discovery, forever circling as a reminder of the moment we first peeled back the wrapping and gazed into the infinite. Our final object is a ghost with no name, a simple designation in a catalogue that hides a profound mystery. Official tracking networks have followed an object known only as NOOU-1 for decades. Its name is an acronym standing for None Other Unidentified, a label of pure bureaucratic admission that we do not know what it is. Its orbit is bizarre, a long, looping path that swings it from high above the Earth to a point much deeper in space, an elliptical journey unlike the neat, predictable circles of most satellites. This is not the orbit of a typical communications satellite or a piece of spent rocket booster. It follows a path that would be incredibly inefficient for any conventional mission, burning far too much fuel to be practical. So what is it? The leading theories are as varied as they are compelling. It could be a fragment from a secret military test, a piece of a rocket stage from a clandestine launch that broke apart and left this single, telltale piece of evidence drifting in a strange orbit. Perhaps it is a natural object, a small asteroid that was captured by Earth's gravity eons ago and has been overlooked until now, a temporary moon that is not a moon at all. Or the most tantalizing possibility of all, it could be something else entirely, a piece of unknown hardware from a forgotten era of spaceflight, or even a fragment from another world's exploration, a piece of debris from a mission not our own. The very existence of NOOU-1 is a quiet testament to the limits of our knowledge. We can track its position with incredible precision, predict its path for years to come, and yet its origin, its purpose, and its true nature remain locked away in the silent dark. It is the perfect conclusion to our journey, a final, enduring question mark hanging in the void, reminding us that even in the carefully mapped space around our own planet, there are still shadows, and within them, ghosts we have yet to name. From historic pioneers to frozen waste and cosmic roadsters, our journey through the orbital attic reveals a bizarre legacy. We have surrounded our world with a museum of our own making, a collection that is equal parts brilliant, accidental, and utterly strange. Each object tells a story, from the defiant final song of a zombie satellite to the silent, endless voyage of a lost glove. Yet this expanding cloud of artifacts is more than just a curiosity, it is a growing hazard. Every lost tool and every shattered satellite fragment becomes a bullet in a cosmic shooting gallery, threatening the very future of space exploration. The silent ocean around our planet is no longer pristine, it is becoming a crowded junkyard. This is our footprint in the cosmos, a permanent record of our first steps away from home. So the next time you look up at the night sky, remember the ghosts we have left among the stars. What do you think is the strangest object we have sent into the void? Share your favorite cosmic oddity in the comments below. But what becomes of this growing celestial museum? The ghosts we have met are not static, their stories are still being written, and their final chapters depend on our actions today. The same ingenuity that littered the void is now focused on the monumental task of cleaning it up. Imagine a silent hunter spacecraft sneaking up on a derelict satellite. With a precise mechanical thump, it fires a harpoon, piercing the metal skin of its target. Another concept uses a vast, weighted net cast like a cosmic fisherman to ensnare tumbling debris. There are even more advanced proposals involving targeted lasers, which would use the subtle power of light itself to gently push smaller fragments into lower orbits, hastening their fiery demise. These are not science fiction concepts, they are active missions in development, a global race to develop the garbage trucks of the 21st century. So what is the ultimate fate of our 30 strange objects? For the majority, the future is a controlled or uncontrolled re-entry. Vanguard 1, that ancient pioneer, will one day feel the faint tug of an atmosphere it helped to measure, ending its centuries-long journey in a final brilliant streak. The Tesla Roadster, however, is on a different path entirely. Isolated in its vast solar orbit, it is likely to remain pristine for millions of years, a time capsule from an era when humanity first began to play among the planets. The real urgency lies in low Earth orbit, the crowded highway where a single collision could trigger a cascade, turning our access to space into an impenetrable shell of shrapnel. The fate of the Lost Glove, the zombie satellites, and the toxic reactor cores is inextricably linked to our success or failure in this new endeavor. This is the next great frontier, not just exploration but stewardship. We are learning that the final, weirdest thing we might leave in space is a legacy of responsibility, a commitment to ensure the paths to the stars remain open for all the generations to come.